what we want to do today, basically what we want to do today is to learn how to compute the efficiency scores. Remember the last time we met, we indicated that DEA constructs a piecewise. So you remember that we took a piece. We took a piece from DME1 to DME2. We took a piece from DME2 to DME4. And those that we are taking, we didn't take a piece from DME2 to 3 because we were taking the extremes. So that is why DEA is sometimes called extreme value analysis or outline analysis. Okay, extreme value analysis. You've got to take note of some of these points. Or outline analysis, because you are picking the ones on the outliers and using them to construct the frontier. But you are drawing a line. So these lines are piecewise linear lines. Piecewise linear lines. Okay, and that is what we are doing. Piecewise linear lines. Now, once DEA has done that, so you have the data sets, you now draw a line on the extreme to envelope the data set. Once you've done that, it will then identify a subset of firms that are on the frontier. Okay, so the subset of firms, the DME1, the DME2, the DME4, DME5, these ones are on the frontier. And now it will identify these guys automatically on the frontier. And then it will do something. When we say they are on the frontier, what we mean is that they are on the boundary of the technology set. The technology set is also known as a production possibility set. Okay? So these firms are on the boundary of the technology set. And those firms are the ones that envelope all of the other firms. So the production possibility set is made up of what? Who can tell me? The production possibility set, it is made up of what? Raise your hand. The production possibility set is made up of what? When we say the technology set, what is it made up of? What is the technology set made up of? It's made up of what? Adiaba, tell me.
Doc, I think it is made up of the optimal production set.
The technology set is made up of the space and the frontier lines. The space and the frontier line, the production space, okay? The production space bounded by the frontier. So the line itself is part of the technology set and the space is part of it as well. So that's the production space. Now you can see this green space plus the line, that is what make up. So I want you to look at the figure and answer the following questions for me. You raise your hand if you know the answer. Which DMUs are efficient and which DMUs are not efficient? Who can raise a hand and tell me? Which DMUs are efficient and which ones are not efficient? Let me go to Kwaku.
So DMU2, DMU4, DMU6, and DMU1, those are efficient.
Why?
Because they are on the frontier.
Okay. Okay, good. Now, I want you guys to watch the graph carefully. There is a vertical line you can draw, okay, and I'm going to do that here. There's a vertical line I can pick here and draw from DMU1 to the number 1, as you can see here. From DMU1 to the number 1, there is a vertical line I've drawn here. And there is a horizontal line that I've also drawn from number 6, DMU6. These lines, if you now have a DMU, okay, which is located on that frontier star, will that DMU be efficient? If you have a DMU which is located there, will that DMU be efficient? And I'm just asking your knowledge. And I'm not saying that the nature of the question I've asked means that you should give a wrong answer. Don't look. I'm asking, will that DMU be efficient at where I put the star? Who can tell me? Will that DMU be efficient where I've located the star? Yes, Stephen Morris. Stephen, question.
Okay, Doc, it wouldn't be efficient because if we trace, for example, DMU6, if we trace it down, we see number of stars. So if there is any DMU producing on the same horizontal line, it is using more staff to produce the same cells, which is inefficient.
Okay, that is fine. But by the definition that Kweku gave, would that DMU be efficient? Kweku, by the definition that, let me go to McClare. McClare, by that definition, would the DMU be efficient?
Yes, sir. By that definition of the DMU,
say that again.
By the definition that he gave, that the DMU being on the frontier line representing efficiency means that the DMU would be efficient.
Exactly. By the definition that an efficient frontier, an efficient firm is the one on the frontier, then that DMU will be efficient. And therefore, there are two kinds of efficient DMUs. Listen carefully, because this is critical. Okay. There are DMUs, there are technical efficiency definition where the efficiency is said to be weakly efficient. And there is one that is known as strongly efficient. What is the difference? The weakly efficient ones are those that are efficient, but also contain what? Who can tell me? They are efficient, but they also contain what? Morrison.
Oh, please, slacks.
They also contain slacks. And so each time a particular firm contains slacks, that firm is weakly efficient. But you cannot determine that weak efficiency using the original approach of Chance, Cooper, and Rhodes. Because Chance, Cooper, and Rhodes did not distinguish weak and strong efficiency. It was later on that other authors, okay, came together and created something we call non-radial approach, DEA. Like Tone, like Russell, and several other people, and created that, which we shall look at later. So, just theoretically, look at it practically, look at it with your eyes. If a firm is located at where the star is, what it means is that that firm is using the same staff of one. Okay? That firm is using the same staff of one, but the output is producing, as you can see, is almost like 0.5. Whereas the DMU1 is also using the same staff, but the output is producing is 1. So you can see that that is a clear indication of the weak efficiency if a firm is located in the halfway. But by the technical efficiency definition of Chance, Cooper, and Rhodes, that halfway firm will still be efficient, just like any other. So if you get this halfway firm will still be efficient, but it will be weakly efficient if you move away from the Chance, Cooper, and Rhodes definition of efficiency. We'll dig deeper into this. So I just want you to know the difference between weak efficiency and strong efficiency. Now let's move on. Which DMUs are dominated? Let me trick you and see whether you will get some. Which DMUs are dominated? Who can tell us? Which DMUs are dominated? Stephen, question. Which DMUs are dominated?
The DMU 2.
Okay. So the first question you will ask is, what is domination before you answer? Remember, what you cannot define will overwhelm you. What you can define, you can modify. What is definition? That is definition. Definition of something. What is that? The composition, the component, the dimension, and the value of something or anything, okay, for further modification for personalized use. That is definition. Okay. And so if you see me holding this thing, you don't say that it is a remote. You got to rather give a statutory definition, not just the functional definition. Because the first time you saw me use this thing to hit somebody's head, you call it a weapon. What you define is important. So sometimes somebody could define certain things, and then you carry that definition in his life when it is wrong definition. So dominated firms are firms. Who can tell me that? Which firms are dominated? Adiaba. Which firms?
Doc, is firm number 5 and firm number 3.
Why?
DMU 3 and because they are inefficient.
Yeah.
A dominated DMU is an inefficient DMU.
But why do we say dominated DMU? If there is a dominated DMU, it means that there is what? Who can tell me? If there is a dominated DMU, it means that there is also what DMU? For who are it?
So it means that there are dominant DMUs.
They are dominating DMUs.
Okay, dominating.
Yeah.
Dominating DMUs. Yeah.
There are dominating DMUs. And out of one of those dominating DMUs, possibly one of them is a dominant DMU. A DMU is dominated if there is another DMU that is using less of the inputs than it, or it's producing more of the output than it. Then that DMU is dominated. The DMU is dominated if there's another DMU that is using less of the inputs that DMU is using, or is producing more of the output that particular DMU is producing. And that is why this DMU is then a dominated DMU. And when you look at DMU 3, if you look at DMU 3, okay, if you look at it carefully, it is using input of what? Input of 4. And if you should identify, it's using input of 4. And if I were to identify any particular DMU here, let's assume that there is a particular DMU that is located somewhere like there. You will see that that DMU, which is located somewhere there, that DMU is also using the same input of like 4 that DMU 3 is using. But if you check carefully, the output that DMU is producing more output than the output that DMU 3 is producing. As long as it's in the frontier. And so that DMU 3 becomes dominated because somebody is doing better than it. Very important. So DMUs that are dominated are 3 and 4. But that is not all. Because there's something else you got to understand here. So when you have indicated your own thing. You got to be able to understand something here. When you have your own data set, you got to identify all of these. Okay. Now, what should an inefficient DMU do to become efficient? Okay. What do you think an inefficient, who can tell me any of the inefficient DMUs here? And can you tell me what it should do to become efficient? You can tell me. Macleod, what should an inefficient DMU do?
An inefficient DMU should reduce its inputs to
Or,
become efficient, or also increase its outputs.
so why did you leave the output part? Because you were happy. Okay, continue. It should reduce its input.
Should reduce its input to become efficient or increase its outputs while maintaining inputs constant.
Okay, which DMU? Which DMU should?
For example, DMU 3.
Okay, all right. Now, let us now estimate the efficiency scores of all of these variables. And the way you estimate efficiency score, and I mean the technical efficiency score, listen carefully, this is very important. The technical efficiency score is the distance from the origin to the frontier divided by the distance from the origin to the fan. Now, when we are talking about the origin is where the zero is. But because the horizontal line and the vertical lines indicate that zero, the movement will be in the zero line. So the distance from the origin to the frontier divided by the distance from the origin to the fan. Whether it's an input oriented or an output oriented, I'm going to let you take some guesses. So as an example, if you are estimating the efficiency score of DMU2, okay, and we want to do output orientation. Output orientation is going to be the distance from the origin to the firm. So this is it. The distance from the origin. But you see, we are not taking the origin from the origin here. We are taking it on the horizontal line, okay, to where the firm is. The distance from the origin, we start from 2 to the frontier, divided by the distance from the origin to the fan. And in this case, the fan is also at the frontier. So if you are calculating the output efficiency score, technical efficiency, for DME2, it will be what divided by what? Who can tell me? It will be what divided by what? For me, my interest is your ability to know what it is divided by, not just telling me the answer, but your ability to tell me that, oh, it is this divided by this. That is more important to me. Yeah. So it's what divided by what? Yeah. What divided by what? You can tell me. To get an output technical efficiency for DME2, it will be what? Remember, it is the distance. Okay. And when you do the vertical line, you read the distance on the, when you do this vertical, you read the distance on the vertical axis. So the distance from the origin to the fan is what value? Type it in. 3, okay. So that would be 3. And the distance from the origin to the fan is what? It's also 3. Very good. Okay. So the output efficiency, and this is important, okay? The output efficiency, this is how we write it. Output is given by letter phi. Phi. The output technical efficiency is given by the letter phi. And in this case for DMU2, so just write 2. That is equal to 3 divided by 3, which in this case is 1. Now, in this case, in this very case, if we're to do the input technical efficiency, that is going to be theta, not the words. Input is theta. Okay, so input technical efficiency for DMU2 is going to be theta. And that one is supposed to be the same distance, okay, differently, but this time you measure on the input section, the staff. So the input technical efficiency the input technical efficiency is going to be the distance from the origin to the firm divided by the distance from the origin to the frontier divided by the distance from the origin to the firm. And you have to read the value on this input axis because you are doing input orientation. The distance from that origin to where the firm is. You see, you are taking it at the top, but you read it down here. You are reading it down there, okay, because it's the same distance. And if you should do that correctly, you are going to see that the distance to the firm will be 2 divided by the distance from the origin to the frontier will be 2. And the distance from that same origin to the frontier will also be 2. So the input technical efficiency is 2/2, which is 1. The output technical efficiency is 3/3, which is also 1. So in this context, not every context, but in this context, okay, for the efficiency, they are always going to be the same answer, whether input oriented or output oriented. But that is not the same when it comes to the inefficient guys. That is not the same for the inefficient guys. Please note the terminology we use for the output efficiency. That is a phi. Okay? The output efficiency is phi, and the input efficiency is theta. Okay. When you work out the input efficiency, this is very important now. Okay. When you work out the input efficiency, and you are doing input efficiency, okay, so that is input efficiency for a particular DMU. The input efficiency is between 0 and 1 inclusive. It's between 0 and 1 inclusive. But the output efficiency, which is the phi, okay, the output efficiency is greater than 1. The output efficiency is greater than 1. Take note of this. And this is technical efficiency I'm talking about. So that means that the firms, for the input efficiency, inefficient firms have a score of less than 1. Inefficient firms. Okay. Inefficient firms have a score of less than 1. But for output, inefficient firms have a score of greater than 1. Okay. Inefficient firms have. So when you are doing input efficiency, you should know how you interpret it. And when you are doing output efficiency, you should know how you will interpret it, because how you interpret it is important. It's important. And we'll come to interpretation in practically. We use our software and I estimate and come to the interpretation. All right. Any question? If you have any question, you can raise your hand. So let's go to, so all that I said is in the notes here. Okay? Input efficiency, output efficiency, they are all there. You can see that between 0 and 1, and then it's greater than 1. All of that are there. So let's try to find the input-oriented efficiency for DMU3 and DMU5. And this time, I want you to guess before I show you the answer. It is not the exact values you get that is important to me, because since you are using your naked eye, you will not get the correct measurement. But your ability to show how you did it is, for me, important. Now, remember, I'm saying input efficiency. So once I say input, you are going to trace it horizontally. Okay. We're going to trace it horizontally, not vertically. So we want to find the input efficiency we're going to find the input efficiency of this DMU. Oh, I'm trying to work the thing is not. So this DMU called 3. If you are trying to estimate the input efficiency of the DMU, how will you do it? How will you do it? Stephen Morrison, you can come in. It looks like I'm not able to use a cursor well. Yes, Steve.
So, Doc, if it is input efficiency, like you already said, I'll read my figures from the x-axis. So, Doc, please, you have moved it from the graph is no more showing.
Are you on the graph?
Yes, please.
Okay.
Okay, so reading it from the, yes, please. So I'll read it from the x-axis, and per the formula you give us is the distance from the frontier over the distance to the firm. So distance of the DMU to the frontier is 1.5.
No, distance from the origin to the frontier.
Sorry, from the origin to the frontier is 1.5, as we can see.
That's how you traced it, is that correct?
Yes, please.
Okay.
Then distance from the origin to the DMU is 4. So it will be 1.5 over 4.
So your input efficiency is going to be 1.5 divided by 4.
Yes, please, Doc.
Good. Do you all agree with it? Do you agree? If you agree, give me a thumbs up. Okay. That is how you find the input efficiency. Now, how would you have done for DMU5? Somebody else should tell me that. How would you have done for DMU5? McClure. Okay, McClure, tell us.
Yes, sir. So I would have traced the line from the origin to the frontier, which estimated trace, and I got about 3.5.
You will get what?
3.5.
Okay, hold on, let me see.
And then,
So like this.
yeah, then you come down, it reads about 3.5. Then over, that's divided by, from that same line to the DMU, over 6.
So from that same origin to the DMU5, it gives you 6, you said.
Yes.
Okay.
Then equal to 0.5.
So that input efficiency will be what? And what divided by what? I'm actually, you turned off quickly. Let me just. Okay, so when you are talking, you can unmute yourself. I'm allowing you to do that. So Michael, unmute yourself and continue.
Okay, so it becomes 3.5 over 6, which is equal to 0.58.
All right. So Michael says that when you do this thing correctly, just as you're supposed to do, you're going to get the input technical efficiency for DMU5 to be 3.5 over 6. The key point is your ability to understand how the computation is done. Keep this, please, in your memory. It's very critical. Keep this in your memory. Remember that what we are doing is that we are using technical efficiencies. So these are efficiency scores. Okay. And you want to understand that it is different from productivity scores. Okay. It's different from productivity scores. It's different from distance functions. Okay. Distance functions are reciprocals, and I want you to note that. Okay. Distance functions, okay, are reciprocals of the technical efficiency scores. So in the input orientation, you were told that the efficiency score is between 0 and 1 inclusive. The efficiency score, theta. Input orientation, keep it in mind, input orientation. That means that the input distance function, okay, so distance function is it, the input distance function is going to be, because this one is, if you're using distance function, that one will be 1 and above. If you are doing the distance function, it will be 1, and everything will be opposite. So you know the way we said that the technical efficiency is distance to the frontier divided by distance to the firm. If you are doing distance function, it will rather be distance to the firm divided by distance to the frontier. Does that make sense? Does that make sense?
Yes, it does.
Okay.
Yes, Doc, please.
I'm saying this, and I've said it because I know if I don't mention it, somebody will say that we forgot. Please keep that, take note of that seriously. All right. So I'm sure you can now calculate efficiency scores for every firm. Every firm. And of course, if you wanted to use distance function, you just need to use the reciprocals. Reciprocals means that 1 over the answer, and then you are able to get to the distance functions. Okay, so learn how to interpret these efficiency scores with all pomp and with all pageantry. Now, next time, and again, what we've done is that we've done the input oriented. Okay. What I want you to do is to go and calculate the output oriented efficiency scores. Okay. Calculate the output oriented efficiency scores. Okay. We'll come and look at the merits and the demerits of DEA, and then the assumptions of DEA. And then now we can now get to proper formulation of the mathematics. Okay. The merits and the demerits, and then we can look at the proper mathematics. Any question, because I'm going to ask you what you have learned today. And you know, any question so far, any question at all. You're happy?